All right, by now you should be pretty good with geometric series, the finite ones. Okay, the idea of this lesson is to look at infinite geometric series. So instead of having, say, 20 or 30 terms, we'll have an infinite number of terms. Okay, think there's a million terms and you're trying to add them all together. So I'll look at this in a little scenario. So a student standing at one side of a road that's 8 meters wide, and he walks halfway across. So let's draw a little picture of this. So here's the road, 8 meters wide. He starts on this side and walks halfway across. He gets there. The student then walks half of the remaining distance across the road. Okay, so he'll go halfway and then he'll go halfway of the remaining distance. Okay, then half of the remaining distance. Okay, and so on, going half each time. So if I was to try and find how far he walks in total, let's have a look at what he does. So in the first little bound, he's going to walk 4 meters. Okay, 4, half of 8. And then he'll walk 2 meters, then 1 meter, half meter, and so on. Okay, so the total distance he walks will be 4 plus 2 plus 1 plus 0.5 plus 0.25. I should probably use fractions. Sorry if you've written that already. Plus an eighth plus, and it keeps going on. To show that it keeps doing on, put these 3 little dots here. Okay, to show that it continues on. Okay, this is called an ellipse. Okay, and it means to continue on the same way. Okay, so we want to see what's the total distance he walks. Let's just add some of these together. So I'll do this in Excel. So I start at 4, add 2, add 1. I should do this properly with a formula. Okay, so each time is going to be half of the one before. So if I scroll this down, I start getting these really small numbers. If I want to add them all together, okay, I'll find the sum of all of these little steps that he's taking. Okay, I end up essentially with 8 meters. Okay, so essentially the scenario is an infinite series. Okay, if he keeps walking half all the way, he's essentially going to get to the other side of the road. Okay, get really, really close to it. So that's the whole idea, being able to add series like this without having to go to Excel and manually add them. Okay, so we do have a formula for this. This is our standard geometric series formula. Okay, the one that you know pretty well. Okay, we can rearrange it to the form that we always use. So this is the form that you guys are used to. If we look at our expression up here, we know the first term is 4 and the common ratio is a half. Okay, we're multiplying by a half each time. So when we look at this sum of n terms, imagine that n is infinity. Okay, imagine we're finding the sum of infinity terms. I'll write it on the other side. Okay, so a is still the same. We'll have 1 minus, okay, whatever r is, but this will be to the power of infinity divided by 1 minus r. Okay, we just want to focus on this term here, the r to the infinity term. In our problem, we know r equals a half, so this r to the infinity is really going to be a half to the power of infinity. Okay, a half multiplied by itself, infinite number of times. If I just do one of these demo calculations like 0.5 to some big power, okay, to the power 50, I get a really small number. This is 0.15 zeros, 888. Okay, if I do 0.5 to an even bigger power, like infinity, we'll just put in a big number here, essentially get 0. So the idea is, in our formula, this r to the infinity term is essentially 0. It's going away. And all we're left with on the top line is a times 1, which is just a, and the 1 minus r on the bottom. Okay, so if we want to find the sum of infinite terms, there's our formula here. We'll put a box around it and color it in green. Green, because green is good. Okay, to find the sum of infinite terms. To check that this works, let's try the formula using our scenario. Okay, the sum of infinite terms. Know that a equals 4, r equals 1/2. Sub in these values. 4 divided by 1 minus 1/2 into the calculator. 4 divided by 1 minus 0.5. Okay, I get my 8. Okay, just like I got when I just added heaps of terms together. Okay, so that's the idea. And there's heaps of practice problems for you to go about having a go at those. So right now, I would expect you to go have a crack at exercise 8B, question 8 ACE, which is essentially just practicing that formula. Okay, so go do that. Go do it. Okay, and then we've got some problem solving that we can use that infinite series formula. So I'll have a look at this one. This is probably one of the harder problems, so hopefully you can do some of the ones in between, like question 10 or question 13. The sum of the first 4 terms of a geometric sequence is 30, so I'll write down that information. Sum of the first 4 terms is 30, and the sum to infinity is 32. So the sum of all the terms is 32. And it says find the first 3 terms of the sequence. Okay, so I'll have a go at doing this. To find the first 3 terms of the sequence, this means find this formula. Okay, you'll need to use this formula, which means we need A and we need R. Okay, if we're ever asked to find the first 3 terms, or if we're asked to find the 70th term, we need to know what A is and what R is to be able to generate those terms. Okay, so I've got to somehow find A and R just using that information. So I'll have a go. I know the sum of the first 4 terms is 30. I also know that if I'm trying to find the sum of the first 4 terms, I'll find that by using the sum of a finite series. Okay, just using that normal formula that you've been using for the other questions. Okay, and I also know to find the sum of infinite terms. Okay, I find that using the formula that we just used, A over 1 minus R. Okay, so I know what the outcome is, I know what the formula is, I should be able to combine these together. So for the first 4 terms, I know that 30 will be A equals 1 minus R to the power 4 on 1 minus R. This will be equation 1. And for the infinite terms, I know that 32 equals A on 1 minus R. Okay, this will be equation 2. So I've got 2 equations, 2 unknowns, need to try and solve for either A or R. The way I'm going to do it is rearrange equation 2. Okay, to get A by itself. Okay, and then I'm going to sub equation 2 into equation 1. Okay, like I said, it's a pretty hard problem. So in equation 1, where this A is, I'm going to put this in there. I'll do it in a different color so that you can see it. So 30 equals 32, 1 minus R times 1 minus R to the power 4 divided by 1 minus R. Okay, so see how that A is just being replaced by that red there. I can go cancel, cancel, because they're all multiplied by each other. Okay, and then go ahead and solve. So you have a go at solving it by yourself and see how you go. Okay, just dividing by 32. Okay, and then try and get r to the power 4 by itself. So I'll subtract 1 from both sides. And I don't like that negative in front of the r to the power 4, so I'm going to multiply both sides by -1. So it'll be minus 30 on 32 plus 1 equals r to the power 4. Alright, so from here I can find whatever the fourth root is of minus 30 on 32 plus 1. Okay, that'll be the r value. Remember, whenever it's a even power, I need to do plus or minus. Okay, so I'll go to my calculator and find what this fourth root is. Okay, make sure, do good drills. Remember, we don't put the plus and minus in our calculator. We'll just get this result of a half and know that it's plus or minus. So the r value can either be plus or minus 0.5. Okay, so we're going to end up with two streams when we're finding a. So I'll have the r equals 0.5 stream and the r equals minus 0.5 stream, and see what happens. So I've got this formula that I rearranged for a. I'm going to use that to find a now that I know the r value. Okay, so sub r equals 0.5 into a equals 32, 1 minus r. So 1 minus 0.5. Okay, I'll get the first term is 16. On the other side with the negative, I'll do the same thing. Okay, sub r equals minus 0.5 into a equals 32, 1 minus 0.5. Remember, I'm subtracting a negative number. Put this in my calculator. I end up with 48 as my first term. Okay, so it says find the first three terms of the sequence. Okay, so I want to find what T1, T2, and T3 is. I'll use my formula. T1 is a, well, we know T1 is just the first term, but we'll use this formula just the same. So I'll write the formula up here. Tn equals a r to the power n minus 1. And I'll sub in a and r. So for T1, I know it's going to be 16. So it'll be 16 times 0.5 to the power 1 minus 1. I'll end up with 16. For term 2, 16 times 0.5 to the power 2 minus 1. I'll end up with 8. Term 3, 16 times 0.5 to the power 3 minus 1. I end up with 4. So one of my answers is that the first three terms are 16, 8, and 4. My other answer on the other side, first term, 48 times minus 0.5 to the power 1 minus 1. Okay, my first term is 48. My second term, 48 times minus 0.5 to the power 2 minus 1. Okay, I'll get minus 24. Term 3, same thing. 0.5 to the power 3 minus 1. Okay, I'll get 12 there. Okay, so the first three terms could be 16, 8, and 4, or 48 minus 24 and 12. Okay, so you're going to be really solid at your simultaneous equations, okay, and just have a go at these problems.